Hello, friends. Welcome back. It's been a while. I want to try to jump back into where we left off way back in December, which, yeah, a long time ago. So sorry about that. We were working on this little statically typed compiler with type inference, and we were doing it in Ruby. And if you didn't see that, then you can go back and catch up on that. I had not even pushed the code for this up to GitHub until today. So now I have a repo for this. So now it has a real thing. You know, it didn't even have a name back then. It was just compiler fun. I think I called it stuff or something. So for now, we're going to call it Maya. It's a working name. I don't know. We might come up with something else, something better. But where we kind of left off was we were able to compile this Fibonacci example and run it. And we're running it with a VM inside of RubyLand, but it does have a compile phase where we compile it into our own little intermediate instruction set, and we're able to run this. So that's pretty cool. It's able to infer the types of the variables, which is just basically one, but it knows the type of fib, what, you know, the return type of this, and knows the type of n, and so on and so forth. So that's pretty cool, but I want to get rid of, or maybe I'll just leave it, but I want to start building a JIT with Llvm. I want to compile it into a proper binary, either ahead of time or just on the fly. You know, executing with a JIT is fine. Either way, I want to use Llvm, and I've been fiddling around with this a little bit, so I have... if you want to take a look and skip ahead, you can see some of the work I've done on type inference experiment. I added a JIT over there. It's not quite done, but I want to do it in our Maya thing, in our Maya project. So here we are, making another video. Sorry for the long intro. I'm kind of out of practice making videos like this, so we'll see how I do. So here we go. By the way, I have switched over to Llvm. If anyone's interested, I have really been enjoying it, and Llvm has been really, really good. So if you see some new stuff here, or me struggling with my editor, that's me just trying to learn some new stuff. I don't even know where to start. I guess we want Ruby Llvm. Jim, Ruby, is it Ruby Llvm or just Llvm? I think it's just Llvm. And I when I was playing with this before, Ruby Llvm. When I was playing with this before, I found a little bug that would not compile on Ubuntu. So I've forked this, and we're gonna use this fork for now. Git. Because I could not get this to compile on Ubuntu. So let's put this at the top so it's not yelling at me, and we'll do get out of this. Okay. Maybe it is Ruby Llvm, and then when you require, it's just Llvm. I cannot remember. Yeah, that looks better. Cool. Well, that did compile, and it built I already had this installed, so it built really quick. And then the other thing we want to do is start on some specs. I think we'll just copy the VM spec to our JIT spec, and we'll say JIT, and compiler, that step will be the same, and we'll do jit.new instructions.io run, and evaluates. I guess that's fine for now. It's kind of like a VM term, but that's okay. Oh man, we have a lot of specs here. That's cool. Let's turn off diagnostics in that file. That's a little bit much. And I need a way to run this. What if I do rake spec? Does it even run at all? Rake spec. It does not. It didn't. Why did that not run? Because I was adding them manually here. That's fine. Put that in order. Okay, that's kind of what I expected to see. And the other thing I've gotten in the habit of doing is making this watch command. So I just do shls **rb, pipe it to entr, which is a fantastic little binary. You can go to entr project, I think. Yeah, entr and download this thing. If you've not used it before, it's really, really great. So I want to clear the screen. I want to run a shell command. I want to run bundle exec rake spec. I just want to run that every time and rake spec like so. And I don't know what's going on with my machine here, but I have to run bundle exec rake spec, and that oh yeah, let's try that again. That's still not working. Rake watch rake watch. Yeah, that's what I wanted. There. Now every time a file changes, it will run that. That's what I was going for. And let's close that, and don't need that anymore. So we want our JIT file. We'll do that here. I forget how this works. No, not copy. New? No. How do you make a new file? This is my Llvm add. A for add. Okay. Let's do a JIT.rb class JIT. Actually, now I wish I would have copied this because I think a lot of this is going to be very similar, actually. Yeah, let's delete that, and let's do this, and let's copy that to JIT.rb, JIT, and I'm not sure about all of this stuff yet. All I really need right now is it to evaluate some integers. So I'm actually trying to remember how to close the other buffers. Oh, how do you do that? I guess I can just close it with this. That'll work for now. I know there's a keystroke for that. B delete buffer. How do you switch to BB? Okay. That's not exactly what I wanted either. Okay, who knows? I'll use the mouse like a noob. So we have our JIT file, and it's going to iterate over the instructions, and it's going to execute the instruction, but we don't want to execute any instructions. We want it to build something. And for that, I need to go look and see, let's see, 7 Ruby Llvm. I need to see some sample code because I don't remember exactly how this works. So I want to require some files. We'll do that up here. And then we want to create a module. I think that would be here. Maybe. So we'll say this is the module, and it's, I don't know what to call it. We'll just call it JIT for now. And we want to, I think we need to add sort of entry function, maybe? Yeah, we need to add a main, kind of like this. And then we're going to need the rest of this stuff. So let's just stick this somewhere for now. I don't know exactly where it goes, but we'll just put it right here for a second. So the module functions, we're going to add a main. It takes no args and returns an int32. I think that's fine. Yeah, for now, it can return int32. Function, we have to have a block, so we're going to build a block, and then we're going to have a b. I kind of want to call this builder just to make sure it's clear what's going on here. And then this stuff, we can just say, we'll keep the 0, and we'll say return 0. And that's builder. And main dump. I don't want to dump it. I don't want to dispose it. I don't think. Let's get rid of that. We want to init the JIT. We want to create a new engine. We want it to run the function and then dispose of itself. Okay. So what happens if I just run that? This is still not happy, so probably up here. VM spec helper. How was I? There we go. We'll need to add JIT here. Okay, something is happening. So we expected a 1 and we got a nil. Very good. So JIT. For some reason, I kind of expected this to return 0, not nil. But I guess I'm not returning the value of that, am I? So what happens if I print this? What do I get? I get a generic value, and if I do 2 pointer, what do I get? I get this pointer, and if I get 2i, what do I get from that? I get a really big number, but what if I leave off the 2 pointer? I get a 0. Okay, so let's say this is a 10. Let's just stick that there. Do I get a 10? Yes, I get a 10. Perfect. So this code works. I feel pretty confident about that. It's building a function called main, and it's just returning the number 10. We'll leave this in here for debugging. So actually, if you want to see what this looks like, this is kind of fun. Oh, not mod. How about module dump? So this shows the what do they call this? The Llvm. It's not bytecode. It's their there's a word for it. It's escaping me. It's their intermediate language that you can write and you can compile directly if you want to, but this shows what that looks like. So this is kind of what it's generating. And then of course, if you could probably mentally translate it into like C code or C++ code or whatever. Yeah, there's a word for that. I just, don't know what it is. Cool. Well, now what we actually want to do is pull up our JIT spec here and have both of them on here. So I want to execute a 1 and I want to get out a 1. The simplest possible thing. And if I uncomment this and I print out the instruction, let's focus this test and go look. So let's just have one test running. So this is a push int instruction, and I forget how do instructions work. It really has been a long time since we worked on this. So we have an arg and an extra arg, and then a name. Okay. So over here we can say p instruction.name and arg and extra arg. What do we get? So the name of it is pushInt and the arg is 1 and there is no extra arg. Okay, so the arg is what we're interested in here. And we want to, instead of execute, let's call it build and stack.pop. I don't think we want that at the end. Do we want that at the end? Probably not. Okay, I think I want all this inside of main. So let's stick that here. And we want to return what was on the stack, not poop. Stack.pop. Builder return stack.pop. So whatever we put on the stack, that's what we want to return. I think that's how we want to do it. So we want to build the instruction. Index can be 0. That's fine. Init JIT. So, but this would be return value. And for now, we're just going to say 2i and pretend that every return value is always an integer. Return value. Okay. Down here, push int. We're definitely going to need a push stir raise to do. This will be our 1. This will be our value 1. Oh, this has to be build. Okay. But we want to do a integer. I think that's, oh golly, what did I do? Llvm int. I think you can do it like this. Does that work? Stack.pop. Stack? Did you mean stack? Well, I did actually, yes. Let's do apt stack. Well, that actually passed. I'm really shocked that that passed, honestly. But I mean, it's doing its thing. If we change this to 10, I assume we'll get a 10 out. Yeah. Or 1, 2, 3. Well, that was easy. Maybe we should try strings as well. Yeah. So focus. So foo must equal foo. So both of these tests can run. Okay, this one definitely errors. That's good. Let's comment this out again. I don't like how it's commenting that. And then we had our to do. Okay, so for this, we'll do stack. Now, I know this is different because I saw some code over here. We want to do a constant array string, I think, and then we've got to do this gep thing, which I get element pointer. It's almost okay. I'm just gonna say what I think it is because I've read this page 3 times and I still don't fully get it. But my mental model is that in Llvm you have you can have a pointer to a thing, but it's not like what I'm used to as a C pointer. A C pointer would point to the beginning of a string. This is more like a fat pointer or a smart pointer or something where it has more information. But to get out the simple C style pointer, I have to do something like this. That's sort of my mental model. And I'm sure I said that wrong, so don't hold me to that. But you can go read this page, get element pointer right here, and maybe you can understand it better than me. But anyway, we want to do this string thing to generate a string. And I don't think it's as simple as what I'm doing right here, but you know, you kind of just got to start somewhere. Excuse me. Unable to allocate function return. Okay, so the problem here, I think, well, I'm sure a problem. I don't know if it's the problem. A problem is that I set this return value to N32, and then was there another place? Oh, and the other place is right here. So we need to know the return value of our main function. Well, guess what? We do know the return value of our main function because this is a type inferring compiler. We have type information in our instruction type. Instructions with no type. We call dot type on it. I don't know if I have to call type bang or not. I actually can't remember, but I think we can get the type out. So what if I say instructions dot last dot type? What do I get out? I get an int and a string. That's what I would expect. Int for the first one, string for the second one. So let's do this. Return type equals this. And then for this one, we're going to say Llvm return type. And let's make a method down here. Def Llvm return type. Let's just say type. I guess it's not a return type. It's just a type. Why did I think that would work? I don't know. We'll say case type. When it's an int, then we want to return an Llvm int 32 for now. I think maybe I'll just do 64. When string, then I want to return type. I don't remember. I figured this out already. I'm just gonna go cheat. I can't remember exactly how I did this. Type. Really? No autocomplete? Nothing? No help at all? Okay. Yes, this is the one. I want it to be a type pointer, LLVM uint. Was that over here? Is that where I got that from? It might have been like this thingy here. I don't know. Okay, well, we're gonna go with that. I was gonna say this is a pointer to an unsigned 8-bit integer, which is basically a character pointer and LLVM speak. And we'll say else raise unknown type. Okay. What happened? What is happening? Yeah, because I renamed that. Let's say LLVM type. Okay, well, that didn't really help. Well, actually, it broke the other one as well. So, was the only difference that was an int 32? No. Cool. What did I do wrong? LLVM int 32. That's the return type. That should have not broken the int case. So what have I done? LLVM type, return type. Let's just print this out. What am I getting back? Getting back a pointer? What is return type? It's an int and an int 32. Oh wait, so that one's working. I guess they were just running out of order, the other order. So that works. Unable to allocate function return number 3. Okay, so this looks good. Color return stack up. Okay, I think that the problem is here. I think that I can't just return a string. I think I have to store it somewhere. And the way you do that, I believe, is to do a builder dot. Oh, where's my builder? I need my builder. Builder. Okay. Builder dot alloc, I think. I did this over here again, just cheating. Builder dot. Yeah, so we create the value, we allocate it with a type. Yep, just gonna copy this. And val is that other thing. Where did my type go? Good grief. It's really gone. Stink. Okay. I had it right here. There it is. Are you kidding? I want this pasted. Whew, that was bad. Okay, so the value, we need to allocate it. I'm going to dump this out so you can kind of see what it looks like. Then we want to store it. Then we want to load it back out. And then we want to stick that on the stack. That didn't fix anything. Builder store variable. I create a variable. I store the value in it. And then I load it and I stick that on the stack. Oh, well, shucks. The integer one works. I'm gonna allocate function return. Well, this is the part where Tim stares at the screen for a while. And hopefully I'll cut this out in post so you don't have to stare at me. But I also like being transparent about just that things don't always work like you think they should, you know? Sometimes you just have to sit and stare. I have missed something. So I have the return type. This is supposed. Well, let's just see if we are getting return value. Let's see. Return value. Value equals stack pop. Let's just print. What does that look like? Does that look like what we would expect? It's a pointer. Wait, what am I printing? Turn value. That's the only thing I'm printing. It is a load. I'm getting the right thing. What if I dump? Can I get that out? Can I dump it? Okay, this looks interesting. So we have our main, takes no args. We are allocating 4 8-bit bytes. The string is foo plus a null character. And then we're storing this in the pointer %1 in the stack allocated variable. And then we're loading it back out again. The problem might be that that's on the stack, and that probably bad. Yeah, how did I get that to work before? I thought that was working. Yeah, this was a mistake. So I'm sticking it on the stack, but this definitely worked before. What am I doing wrong? I'll need this in a minute. Oh, the gep thing. That's it. Yes. I talked about it earlier and then I completely forgot that I need that. Okay. The issue aside that I'm allocating something on the stack and then returning that value. This this is bad, but we'll fix that in a minute once I figure out how. But the real issue that's causing the failure is that like I said, that pointer is not the kind of pointer that that we need to get out. So I think I want to say case return type when int. Nope. Yeah, when it's a string, then I want to do builder.ret. Paste that, return value. And we had a 0 over here. 0, 0, 0. Where is our 0? It's right here. Everything else can just do builder.ret turn value. Do I like those prints? I don't know. I think that's probably good. Does that get us anywhere different? Maybe. At least it's not bombing. And then we can comment that. And then I think the other issue is here. We can say if return type, let's say case return type. When it's an int, then we do this. And when it's man, my indentation, oh, that's really bothering me. Then actually, let's do this. Value equals paste that. Value to pointer dot read string, and it took me a lot of experimentation and reading source code to figure out that one. That one was interesting. Does that get us passing? Yes. Okay. So let me figure out what is a better way to do this. Let's dump that out again. It's not allocating that as a global anywhere, right? So it really is sticking it on the stack, and we're just lucky that it's still there. There's that get helmet pointer thing, which is so weird to me. I don't even know. I don't even know. But I really want this string to be somewhere else. Do I need to malloc it? Is that what I want to do? I could do what they did just to get us kind of back on track and wrap up this video. I could do this, or I could say if it's a string, then let's see, fix me don't always want a global string here probably, but for now let's paste this and let's do instruction.arg. What is hello? Is that the name of it? Goals add. Do I care about the name? Maybe I don't. I'm gonna say string I guess I have to do this twice. This seems redundant, but I'll put that there. And then can I just put that on the stack? Does that work? No. Oh, because it's mod module. Wrong number of arguments. 1 expected 2 for 74. So I have to give this a name. String. It does seem like this part worked, but for some reason I'm not doing the get element pointer thing. Why not? None of that should have changed. This should still have the get element pointer. Let's just focus the one test and then let's print return value and return type. So that's our global variable pointer and the type is string. Okay. So right here, I'm doing gep. Okay, how did they do it over here? Main gep hello cast 210. I'll puts with that. Why can't I return this? Hello, hello. Is it the name? Does the name matter? I don't think so. Stir. Here's my stir. But I'm just returning a raw pointer. But that's not what I told you to return, silly. Silly, right here, told you return get element pointer. Return value. I mean, I don't know why that wouldn't just work. Global value pointer, pointer address. What was it? Oh, I wish I would have saved all that. Okay, let's just undo. Actually, here's what we're gonna do. We're gonna let's add all that to the index, and then let's undo this until we get back to what we had before, the bad stuff. So that was passing. Okay. What does p return value, p return type, and what does all this look like here? Yeah, that's an instruction. Fascinating. This is an instruction. Oh. Okay. So earlier, this didn't say instruction. It said pointer or value or something like that. So I guess if you pass a non-instruction into this gep, it does the wrong thing. Okay. Now the question is, why was that not an instruction? Why was it not an instruction? I don't know. Okay. Let's put it back to the code we want. And then unused method. Well, fine. I don't know. I'll need that later. Maybe I have to put that on the stack. Okay. It's like I need some sort of instruction. Wait, did they do that over here? B gep hello. Well, shucks. Okay, we'll do it this way. We'll say that that's the value. Then we're gonna do. We're gonna allocate it, store it, load it back out. Probably not the best way to do it, but I don't know how else to do it. So we're gonna say stir. This is the var, and then we're gonna do that stack. What does that get us? Oh, a big stack trace. Fantastic. Oh, that's just amazing. Yeah, fun times. Okay, well, these are really just the best. The best. Does this give me something I can use? 45 is the line it really blew up on. And that's when I'm running the function. Okay, so I'm generating the code. What if I return 0 here? Does that stop blowing up? Okay.
A few moments later.
Well, I think I have the answer now. It's been, I don't know, an hour or so, just trying to get my head wrapped around this problem. I took the dumped output that we got from our JIT, I put it in a file by itself, and I ran it through LLI, which is the Llvm assembler, and got an error. so rather than this giant Segfault that was not helpful at all, I got a real error. So that helped. And then I fiddled around and took off one of these zeros on get element pointer, and that error went away. So that was my first clue. Okay, so again, remember when I said I don't fully understand get element pointer? Yeah, that's where we are. I think there's something different about this global string than when I had allocated the space on the stack, and I don't know the difference yet, but I do know that 1 0 here, dereferencing the pointer one time works here, whereas before I had to dereference it twice, to had to have a 0 0. Okay, so there's that. And then over in Ruby Llvm, there was a test that I saw where they were doing essentially the same thing, creating a global that's an array of bytes. They did set the linkage to internal, and I fiddled around with that. Didn't really seem to matter. And then they did get element pointer with 0 0 and pass it into a function. Okay, but one other thing they did differently was they called pointer read string. Interesting, right? Don't know why you would need that, because what we were doing before is pointer read string. Cool. So there's another thing I need to learn, is why do we have to read pointer read string here? And yeah, that doesn't make sense. But anyway, all that to say, the answer seems to be if I change this to 0 and I uncomment the code and I run this, then I don't get the Segfault. I just get the wrong value. Instead of foo, I get a blank string. But then I go down here and I say read pointer.read string, and things start passing. Okay. Why? I don't know. I don't know why that is the way it is. I have some more to learn. We're just going to leave it at that. For now, we are going to run all the specs, make sure everything passes. I'm going to commit this and call it good for now. It's just brutal. Do we want any of this global constant linkage private? Does it still pass with that? Yeah, I don't know. I don't know if any of that matters, honestly. I kind of just want to leave it like this. That seems good. Yeah, everything's passing. Let's commit this. Let's remove all our watts, remove our hello that we added off screen, and then I think we can add everything else. Okay, so what did we do in this video? Well, we added integers really quickly to our JIT. We added a JIT and then we added integers really quickly. That was super easy. Then we tried to add strings and got thoroughly confused by get element pointer and how to dereference pointers and stuff like that. So I'm very sorry. I don't know how to teach you because I don't know how it works, obviously. Very sad about that. But we did get it to work, and I think that's success for this video. I think I'm going to call it success. So thanks for hanging out. We're going to say add JIT with Llvm. We're going to push that, and I'm going to wrap up this video. Well, thanks for hanging out. It's like I said, it's been a while since I made a video, kind of out of practice. It's been a while since I worked on this project. I've forgotten how some of it works, and I'm trying to learn something new on top of that, which is Llvm, which I thoroughly do not understand. So hopefully you'll have some pity on me if you know the answers to some of why that is what it is. Please comment below and let me know, and hopefully I'll do a little bit of reading and get some answers for the next video. But until then, I guess I'll see you later. Bye.